All right, we're looking at problem number 15 from the quiz. It reads, if a car accelerates at a uniform rate of 4.0 meters per second squared, how long will it take to reach a speed of 80 kilometers per hour starting from rest? So the first thing you should be thinking is, what is this actually looking like? So we've got our car. The initial velocity of the car is 0 meters per second because it reads starting from rest. It's going to travel. Let's say the motion is to the right, and remember that any motion that's to the right could be negative or positive until you define your axes. So we're going to use the normal, positive being up and positive being to the right. We're going to choose that as our coordinate system. The final velocity, well, it gives you a final velocity in kilometers per hour, so 80 kilometers per hour. But it gives you an acceleration, a rate of acceleration uniformly, of 4.0 meters per second squared. So right there, we have a little bit of a problem because our acceleration unit must match our velocity unit. To me, it makes more sense to go ahead and convert the 80 kilometers per hour into meters per second. So if you divide by 3.6, that's the conversion. You get 22.2 meters per second. So the final velocity of this car is going to be 22.2 meters per second. How long will it take to reach that speed? So we're really looking for t. We don't know it. So I'm going to rewrite my variables off to the left. We know the initial velocity is 0 meters per second. We know the final velocity is now 22.2 meters per second. And we also know the acceleration rate is going to be 4.0 meters per second squared. The question is, which equation is going to solve for t? So you find your kinematic equations that you've listed. They're hanging out to the right of your page so that you can easily see them. You wouldn't want to have to keep flipping back and forth in your notes. And we find that this definition for acceleration really has everything in it that we need. So we know acceleration is the rate of change in velocity. So we've got a change in velocity over time, which is v final minus v initial over t. We rewrite. Remember, these are just representing numbers. The algebra is the same, whether it's a variable there or whether it's a value. You still rewrite the same way. So algebraically, we will have t be equal to v final minus v initial over the acceleration. Now I plug my numbers in, so the final velocity is going to be 22.2 meters per second minus an initial of 0 meters per second divided by the acceleration of 4.0 meters per second squared. We run the numbers through our brain first, so we got about 20 divided by 4, so my answer should be around 5 seconds. About 5 seconds. Mathematically, it is actually 5.6 seconds using sig figs that I know all of you love and enjoy. So the question was, how long will it take? To reach 80 kilometers per hour, it's going to take about 5.6 seconds. I hope that helps you. Remember, practice makes perfect, well, hopefully.